All right, well, thank you all for joining today. We're going to start off with a quick overview of what we're doing at SciTech Institute with the Arizona Advanced Manufacturing Coalition, and then we'll move into some presentations from a couple of partners today. And we also want to say a big thank you to Boeing, who is our sponsor for Manufacturing Month this October. And so we want to give a shout out and thank you for helping us make this all happen. So what is the Arizona Advanced Manufacturing Coalition? Here in Arizona, we are so lucky to have a huge manufacturing industry. We have over 5,000 manufacturing companies here in Arizona, and that means that there are over 150,000 available positions in the field of advanced manufacturing in Arizona. And with all of those jobs available and all of these new companies coming to Arizona and opening up their doors, we want to make sure that we are able to prepare our students to go into those fields, make sure that we can meet that need in the industry. And so that's kind of where this Arizona Advanced Manufacturing Coalition started. And so our goal is to connect partners in education, whether it be in high school or middle school, community college, universities, or other CTE programs. We want to make sure that we have everybody connected and understanding the opportunities that are available and how they can get there. And if you weren't aware, we are actually in the middle of Manufacturing Month. Here in Arizona, that is the month of October. And so we've been spending the month with a whole bunch of activities around advanced manufacturing. We have been doing classroom visits. We've been visiting, especially in Mesa Public Schools. We've been going in and talking to students from kindergarten all the way up through high school about what manufacturing is, how they can find those careers and what steps they might need to take to get there. We also hosted STEM community lunchtime conversations on October 14th as a way to show off what some of our very cool partners are doing. We had an episode of SciTech Institute's monthly podcast, STEM Unplugged, and that was focused all about manufacturing. We spoke to some folks from PADT and NPower. Last week, we had our manufacturing career panel where we got to learn about some really cool educational opportunities here in Arizona that can get you started in a career in manufacturing in just 10 days. And then, of course, today we have our manufacturing tech talks. And all of these opportunities are going to be up on our website, which is azamc.org. We're going to add all of this content to the website. It'll also be on SciTech Institute's website. You can find it on our YouTube. For our podcast, you can check it out on Spotify, Spreaker, Apple Podcasts, anywhere where you go to get that kind of content. All right, and with that, we're going to go ahead and get started. We'll start off today with Omar, who is an engineer at Viasat, and then we're going to move on to Brett from In Position Technologies. Thank you all for joining, and thank you to Boeing for sponsoring today's event. And Omar, do you have slides to share? Can I?
Yes, I can share my screen.
Perfect.
Can you see my screen?
Yes, that's great. Thank you.
Thank you, Claire, for the introduction. And thank you for the opportunity to allow Viasat to participate in the manufacturing tech talks and help show the community what we're doing here in our Tempe office. So my name is Omar Alam. I'm an RF antenna systems test engineer at Viasat in our Tempe office at the ASU Research Park. And my presentation today, it focuses on antennas, the science behind them, and how they're used in Viasat's satellites and how they're manufactured at a larger scale here in our office. So just a brief about me. As I said, my name is Omar Alam. I work with RF, which is radio frequency and antenna systems here at Viasat. I'm not from Arizona. I was born and raised in Minneapolis, Minnesota, and I spent all of my K through 12 life there, and then I ended up at Cornell University in Ithaca, New York, on the other side of the country, where I decided to pursue a bachelor's of science degree in applied and engineering physics, a very science and math intensive degree program that got me to where I am today. In 2017, I moved over here to Phoenix and across the country, and I started working at Viasat, where I work on satellite technology. What does Viasat do? You may have heard of us as a satellite internet provider. We do a lot of in-flight Wi-Fi. So if you're on American Airlines, for example, and you log on to their AA-in-flight portal, that's all Viasat based. And we do everything from the ground up, from making the electronics that would go into the satellite to actually manufacturing the whole satellite itself. And then once one of our launch partners, like SpaceX, actually launches our satellite into orbit, we then control the satellite and manage the internet service from space, and manage our in-flight Wi-Fi. And if you're using like one of our dish antennas for Wi-Fi at your house, we manage that as well. And on this slide, I have some images of some of the satellites that our company has built and managed. And since 2004, we've grown faster and faster in the throughput or internet speeds of our satellites. The most recent Viasat-2 launched in 2017 with a 260 gigabits per second capacity to deliver internet from space. And we're working on our Viasat-3 constellation right now, which is a leap ahead of that. 3 satellites, each of them connecting 1/3 of the globe, and each satellite having 1 terabits per second capacity. We hope to launch those fairly soon. Specifically in Arizona, here you can see an overhead drone picture of our facility, and this is in Tempe at the ASU Research Park off of Elliott and the 101. And our facility is not the headquarters of Viasat. Viasat, the company as a whole, is headquartered in Carlsbad, California, which is a little north of San Diego. But Arizona is a very important location in that we design and provide all of the essentials that go into our satellites, networking products, satellite services, and a lot of that is radio frequency hardware, and I'll get into that in a minute or so. In this facility, we design, build, test all of that hardware, and we actually go to the large satellite level as well. So this little taller building structure here in the left part of the picture is where we can actually fit 2 geostationary satellites at once, and a lot of laboratory facilities where we can test our components with high fidelity, order of magnitude improvements in performance, size, and cost. And we just plan to grow from here and have plans to make more buildings. So Viasat's growing more than ever. Next slide. Here, actually, in the picture here, you can see one of our Viasat-3 satellite payloads. So this was one of the newer satellites I was referring to a couple slides ago, where this one in particular would cover North and South America. So these are geostationary satellites, and that they get launched into a very high orbit, 22,000 miles above the Earth's atmosphere. You may have heard of terms like LEO and GEO. A LEO satellite, low Earth orbit, is at a shorter altitude from the Earth's atmosphere, and what happens is that the satellite orbits the Earth faster than the Earth rotates. And what that means is maybe in one, like Starlink, for example, maybe in one day you see them pass overhead 5 or 6 times a day, because they're rotating faster than the Earth rotates in a 24-hour period. But these geostationary satellites, 22,000 miles up, actually match the speed of the Earth. And what that means is, from the Earth looking towards the sky, it's as if the satellite never moves. That's why we use, for example, dish antennas. You point them in one direction and they're connected to the satellite forever, because the satellite's just moving at the same speed as the Earth. And Viasat focuses on this class of satellites. These are much larger. We can pack a lot more power into them, and there's a lot more manufacturing effort that goes into a geo satellite as opposed to a smaller LEO satellite. And you can see some of our team members here in our high bay. They're all dressed up in lab coats, and they have ESD, electrostatic discharge straps. And before COVID, you had to wear masks because you don't want to be breathing all over the satellite components and spreading your germs. So it's a very clean room environment. What goes into a satellite? There's many different types of components. There's the payload, which is this thing in the middle, and that's what I was showing in the previous slide. That the payload is this box in the middle of the satellite that does 95% of the job of the satellite. It's where all the electronic components are integrated, all the computer systems, software systems, and the payload is attached to a spacecraft bus, which has the thrusters and the solar panels and can do like maneuvering in space. And there's radiation shielding. There's the PV cells that go into the solar panels themselves, and then there's antennas. And that's what I work on here at Viasat, and it's an integral part of our satellite technology. Touch on the STEM behind antennas really quick. It's a very thorough subject, and to get a fundamental understanding of antennas, one, you need to master electromagnetic physics and electromagnetic waves. And at the most basic level of that is a wave, because antennas transmit and receive radio waves, and radio waves are invisible and they travel through the atmosphere and through space. But what is a wave? We know mathematically you can represent, for example, a transverse wave as the sine wave. It goes up and down in a very periodic, repeatable fashion, and it just does that forever. And you can have waves at a certain frequency, which is how many times it oscillates per second, or how many times it goes up and down per second. Waves have amplitude, which is like how powerful is a wave, like how much energy is encapsulated within a wave, and we call that the amplitude, or kind of this vertical direction here. And in physics, there's a phenomenon called electromagnetic waves. So there's a branch of physics called electromagnetism, and it explains the behavior of these invisible waves. They travel through space and time. There's an electric field, there's a magnetic field that are perpendicular to each other, and then the wave has motion, it has a speed, they move at the speed of light. There's a lot of physics that defines this type of behavior, and antennas are vehicles to utilize these electromagnetic waves. In real life, you may have seen this before. It's called the electromagnetic spectrum. Starting off at a larger wavelength, we call that radio, then microwave, infrared, visible light. So the light we see are colors: red, orange, yellow, green, blue. Those are invisible electromagnetic waves at a certain frequency, a certain wavelength. And then past that, there's ultraviolet, UV, X-rays, and gamma rays. And Viasat focuses on radio and microwaves because these signals have large enough wavelengths that they can be propagated to and from space, and we can perform signals and communication using those radio waves and microwaves. Antennas are the vehicle to transmit and receive these radio waves, and there are all sorts of antennas: dish antennas, sectors, which go on cell towers, electronically scanned arrays, which is what I work on, and I'll touch on that in a slide coming up. Horn antennas. If you can see me on the camera, I'm actually holding one up. These are like some of the more dish antennas that would go in your house. These would go at the arm, at the far arm of the dish antenna, and it helps collect the signal from the satellite and transmit back to the satellite. Cars, you've seen cars that have these shark fin antennas on them. That's how they receive radio stations and Sirius XM. These invisible radio waves are just traveling all through the atmosphere and through space, and different antennas can pick up different frequencies and different signals. And here's an example of a Viasat dish to get satellite internet, and the horn antenna that I just held up. Very quickly, in-flight Wi-Fi, if you've seen aircraft that have this bump at the top of the fuselage, that's Viasat technology. That's actually our airborne transmit receive integrated assembly, which is this large antenna that goes on top of the airplane and can connect to the satellite that way. And here's one of our older satellites, Viasat 1, with four very large antennas being tested in this anechoic chamber to get the performance of these antennas. And in space, these need to be large. So it's 22,000 miles away. It needs to send a very strong signal back to Earth. What I work on is called phased arrays. So dish antennas, as I mentioned, kind of just point them in one direction and they just stay there, because they're typically pointed at geostationary satellites, and which move at the same speed as the Earth. But if you're trying to track a very fast object, you want to use a dish antenna, you'd have to put the dish antenna on a motor and motor it around so it can track the target, and that can be very inefficient. What an electronically scanned array antenna is more like a flat panel that has very small antennas that come together to form a very large array, and you don't have to move it around like you would like a dish antenna on a motor. These electronically scanned arrays or phased arrays, they just stay flat in one location, and you can write computer software to actually steer the beam or steer the radiation that comes out of the antenna. And these antennas have applications for radar, for satellites, for our newer generations of satellite internet on the ground will potentially replace dishes with phased arrays. And there's very emerging technology that has a lot of room for manufacturing, innovation, and improvements. A day in my life, my title is RF Antenna Systems Test Engineer, and that encapsulates a lot of different roles. I do hardware engineering, where I do a lot of antenna testing, where I put antennas in these chambers and I measure the performance, make sure they meet specifications, figure out any problems with the design. Software engineering, actually writing the code, mainly Python-based, to automate and process the information from these antennas, to program them to do what they do. A lot of laboratory work. This is hardware, and you have to set hardware up, fixture it in the lab in these chambers, and configure them physically, in addition to all of the software that's done to it. And then there's a data science aspect to it as well. So there's a lot of test data, measurement data, performance files that come out of these measurements, and I can use advanced processing techniques like certain libraries in Python to get a visual of the antenna or how it's working, and move it along the line. I just wanted to, before moving into questions and answers, I wanted to leave the audience with this slide here. I mentioned we're working on Viasat 3 right now. On the left here, I have a picture of a component from Viasat 1. This is a human right here in the lab. And this is a whole radio frequency communications panel. You can see how tall it is. But look at Viasat 3's communications panel here on the right. It's the same concept. It's the same, it has the same function, except this communications panel in modern day is much smaller and much more powerful, because you can pack more circuits and and transistors and whatnot in there, and you can stack many more of them inside of your satellite payload to make it a much more powerful satellite in general. So there's a whole lot of manufacturing innovation that goes on here at Viasat. And I've only really touched on one subject, which is antennas, and there's a lot more. And in the future, I hope to do more outreach from Viasat and provide some more education on what we do here. So Claire, with that, that's my presentation. I'm open to any questions from here.
Yeah, that was great. Thank you so much. If anybody has any questions, you are welcome to either pop them in the chat, or you can unmute yourself and just ask. We'll wait a minute. I know I have some questions if we don't have any coming through here. Can go ahead and get started. So my first question for you is, so if thinking about how you got into your position at Viasat and kind of what you studied to get there, what classes in school or what skills did you learn that you think are the most helpful in your current role?
So there's twofold. There's soft skills and there's hard skills. Working at Viasat's a very collaborative environment, and you have to be comfortable working in teams, giving presentations, speaking up. So soft skills are very important. People skills, learning how to speak, how to work in groups, how to collaborate effectively. That's certainly one of the most important things that makes me successful at Viasat. On the hard skills side, I think having an understanding of physics has really helped. We work with technology that flies in space and sends invisible electromagnetic waves out from space and gets collected here on the Earth and gets sent back up. Taking physics is typically like you start out in classical mechanics, then electromagnetism and quantum physics. The electromagnetism part of that has been crucial to my job here. And in my fourth year of my college education, I was able to take some more specialized classes, antennas, microwave circuits, radio frequency engineering, and some of those more specialized concentrations have helped me as well.
Interesting. Thank you. I see we've got a couple questions coming in the chat now. We'll start off with David asks, what technology changes allow VS3 communication modules to be so much smaller? For example, is it mostly about smaller or faster signal processing or improvements in power or RF technology?
That's a great question, and yeah, it's a combination of that. So we're one of our chief systems engineers on the Viasat 3 satellite has posted this great blog article on Viasat.com, and in the past, satellites were like bent. They call them like bent pipe architectures. Like they used bigger types of electronic components, like traveling, like TWT amplifiers. I think it's like traveling wave tube amplifiers. And Viasat has gone to a more integrated system approach using semiconductor technologies like GaN, gas, SiGe, and solid state, CMOS. Throwing a lot of terms out there, but essentially using semiconductor technologies that can enable new types of products like solid state high power amplifiers, whereas in the past we used a non-semiconductor type of process like for older satellites. Software-wise, that's definitely the case. New signal processing algorithms that are called waveforms, which are sent out from the satellite to an Earth station or back, and optimizing how much information can be packed into those waveforms. We have people who optimize the internet itself. So we have a division in Marlborough, Massachusetts, that actually makes we have like our own Viasat web browser, and it takes the Viasat internet signals that are coming from our satellites, and we can use some fancy mathematics and physics to actually make the internet faster on your computer, more so than on the satellite itself. So there's a lot of advancements in hardware and software, and it all comes together.
Interesting. That's a great answer. Thank you so much. Our next question is coming from Elena, who wants to know, what advice do you have for new grads who are trying to connect with companies in your industry? Do you recommend internships, job shadowing, or other things like that?
Absolutely. So we have a great internship program, 12 weeks, and other companies, you know, they might have like quote unquote intern projects, but that's not the case here at Viasat. As an intern, you're put on a team, like a regular engineering project team. Engineers were carrying along their work before you came in, and you joined the team, and from day one you contribute to the more the hardcore engineering that happens here at Viasat, and you can have a real impact that way. We also have new grad positions specifically. So if you're a university graduate, we have positions that you don't need too much experience, and you can get hired as a new grad at Viasat and learn a lot of your skills on the job. I encourage you to go to viasat.com/careers to look at those intern or new grad opportunities, and you could also feel free to reach out to me as well. And we're always looking for the next generation of engineers, and we do anything to attract the top talent.
That's great. It's exciting to hear that they actually get to work on projects right away and not kind of do, you know, the side tasks that nobody else on the team really wants to work on. Exciting that you can get that kind of experience right away. All right, our next question is coming from Amanda. She says her 3rd grade son wants to know if solar power is used in these panels.
Yes, so in space, satellites get their energy from the sun. So the solar panels, let me actually go back a few slides here. You can see like a cartoon picture of a satellite in space, and you can see a reflection of the sun here. And we use the most abundant natural resource out there, the sun, to collect energy and recharge all of the electronics that live on board our satellites.
That sounds awesome. All right, thank you so much, Omar. If we don't have any other questions, you can continue to throw them into the chat as we move on, but we're going to go ahead and switch over to Brett for our next presentation.
Thank you, Claire.
Yeah, thank you so much for joining.
Okay, great. So thanks, Omar. That was awesome. I actually didn't know that much about what you guys do there. So I am going to talk for just a second before I start sharing a screen so you can see my pretty face. And then I will put up the PowerPoint. So I am what you call a sales engineer. I am a mechanical engineer. I graduated from ASU almost a decade ago now. But I chose to go down a slightly different path and go toward more of a sales-focused outside sales, customer solution-driven type job. So I spend most of my time out at other people's companies, helping them, looking at what they're trying to solve, mainly in the automation space. And I'm going to show you some pictures and videos here in a second on what that looks like. So I could easily take a day for something like this to go through all the different types of stuff we do. So it is going to be very condensed, and I'm going to let you guys ask questions and try not to bog you down with a bunch of stuff. So let me get my screen shared here. Zoom's a little different than other things. Oh, and I'm actually having trouble finding it. Oh, there it is. And there. Okay, can you see this PowerPoint here?
Yes, that's perfect. Thank you.
Awesome. Okay, so quick overview. my company is a distributor. So that means that we buy and resell product mainly. Now we are a value add distributor. That means when we buy things and we resell them, we actually do additional work to make them something other than just what they started as. So value add means we take two things, we put them together, we add something else, we add something custom. So we do a lot of work, and that's where the engineering comes in. We also need to be tech support and things like that for our customers to make sure they can use everything correctly. The automation space is not like consumer electronics. You don't just see a TV that you want to buy, you buy it, you play around with the remote till it works. That's not quite what we do. Everything's a little more complex. The industrial space has a large cost for downtime. If you think about a factory that is making thousands of parts an hour, that means that every hour that you're not making those parts, you're losing 1,000 times however much that part was. So could be, $50,000 to $100,000 you're losing an hour by not having your machine running. So it's a really vital thing that we help them keep their machines up and running. And that's why I have a job to help people do that. So here's an example of some of the stuff we do. It could be robots. So we've got an industrial robot arm. We've got mobile robotics. You can see an example of kind of an older style automation, which is what we call Cartesian robots. Those mean they move linear directions. And so this is one that could move in 3 different directions at once right here. You can see some of the custom assemblies that we've done. So you can see another one of those Cartesian robots. It only has 2 actuators there, a gear head and a motor, another gear head and a motor, a very complex multi-axis system. An axis just means a direction of motion. So a multi-axis system means more than one direction of motion. This particular one had 4 different directions it could move all at the same time. Here's some more complex things. So if you've ever heard of the term hexapod, that's what this is. It is can move in all 6 directions at the same time. Some complex things for like optical and metrology, high precision. If you're familiar with what a nanometer is, so a nanometer is so millimeters is 1,000th of a meter. A micron is a millionth of a meter, and a nanometer would be a 1,000 millionth of a meter. These can hit tens of those. So if you think about how precise that is, it's not even really comprehensible by the human mind typically. But that's the kind of stuff we do there. There's something that goes in a vacuum chamber. Okay, so that's lots of static pictures. Let's show you a little video here, see if we can get some questions flowing. And feel free to start typing those in as you get them. So here's a robot. Oh, let me get that sound off. I don't know if it comes through, but we don't need it. So here's a robot that's going to load a CNC machine for us. This used to be a very manual process, and it actually had a lot of mistakes. People made mistakes. They loaded it wrong, and it broke machine tools. So by using the robot, we're able to take some of that error-prone things out of there and make everything work a little better. You still have the people there because they're the ones programming these systems and working on it and doing maintenance and things like that. Just people are doing things that are a little more rewarding and less monotonous once we've got automation doing the boring, repetitive things. So there's one example. So here's another example using the same type of robot here. So this is a totally different type of application. This is using a robot to load some electronics equipment into a testing station. So it's going to get plugged in, and then they're going to run some diagnostic tests to make sure it's good before that gets shipped out. Once again, this is something that someone used to do by hand. And if you could see how long it's taking to change out the units, that means one person's kind of just standing there quite a bit. And if you can imagine, that gets pretty boring. And so they were more than happy to go do the jobs that are a little more engaging for the mind and a little less monotonous. And that gives the robot something to do here. So you can see it's loading 2 different test stations all at once. Sometimes we do things that aren't necessarily production, but it's more of a research and development type of project. So let me jump through there we go. So in this case, we used a little tiny robot to simulate people doing gestures on a phone so that they could do over and over and over and over again so many times to see if something breaks, see if something doesn't work anymore. This is how you test new touch screens to make sure that they're going to last 5-10 years like you would expect your phone to last. And so you can see it's able to draw, it's able to do everything a person might do because it has just as many It's able to move just as many places as a person is. So that's pretty cool stuff. Here's a more traditional industrial type application. So more high speed, it's got a conveyor. In this case, it's just moving parts back and forth as a demo on the conveyor. But you could see it's automatically finding where these parts are using cameras and picking them up and moving them over. And it's just going to do that forever. Once again, it's something a person could do, but they would very rapidly get bored with it and start making mistakes. And, you know, mistakes are not generally in the best interest of anyone. So we like to replace the boring things with robots and let the people do the things that use brain power and that are a little more fun to do. A few more things, you know, little accessories. We can do laser marking. We can do 3D vision, so we can scan things and make a full 3D model just with a camera. And then we can do mechanics, gear heads, rack and pinion type things. And I'm sorry that I'm going through this so fast, but I wanted to make sure there's room for questions, and there's just a lot of stuff we do. So basically what it boils down to is companies bring me in to look at the process that they're doing right now. And that could be some sort of manufacturing, or that could be a product that they want to make. So think of your printers, think of, I don't do this too often, but, you know, think of a washing machine or something like that. Anything that has stuff moving around in it, and they need help finding the right way to move things around inside their system. So printers, laboratory automation, so like blood sample analysis, cancer machines are very common. Any of those things need to move samples around very accurately. And sometimes people need help trying to figure out how to do that. And that's where we come in. So I didn't open the chat. So in fact, it's hiding it from me now. There it is. What questions do we have? Nothing. Does anybody have any questions so far?
And reminder, you can throw questions in the chat, or you can just unmute and ask them. I know I have a question for you,
Sure.
just about sort of how you got into this. I think it's really cool that you're able to work on these solutions that, you know, are on products from all sorts of different fields. You know,
Sure.
It's not like you don't just have to do, you know, aerospace or just medical devices. You can kind of get a wide variety.
So yeah, I totally forgot to give you guys my background. So I actually was in the military. I was in the Navy for about 10 years. I worked on submarines, running the nuclear power plants that powered the submarines. When I got out, it was about the same time the 2008 crash happened. The stock market crash was probably the worst possible time to get out of a job. So I worked for a little bit, but then realized it was time to go back to school because there was no other way to kind of survive in that time. So I went to ASU. I got my mechanical engineering degree. Now I was an electronics technician in the military. So by training, I learned how to replace electronic circuits, troubleshoot them, do things like that. And then I got my mechanical engineering degree. So between the two of those, automation was a very good fit. And I also have a pretty wide background between all the things I've done, so that when I walk into a new facility, walk into a new customer, even though they're doing something that may not be quite directly relevant experience, I can usually draw on the things I've done before to understand what they're trying to do and to get the conversation started. And so, yeah, the way I got started into it was basically I jumped headfirst. You know, I had job offers out of college for more traditional engineering roles, which were, you know, working for a direct company where I'd be doing design work for them. But what I do today is more, I get to do some conceptual design. I get to play around in 3D modeling software to figure things out and help customers find their own solution. But I get to do like 2 or 3 of those a day rather than working on one project for an extended period of time. And that just seems to be a little better fit for my mind, how my mind works. So I did see a question come in about how to make products, or do companies come to me to make products in a more efficient way? And that's absolutely something that we can help with. One of the advantages of automation is typically efficiency, but we can also do studies on that. They might have an existing automation solution that is a little too slow. And so we can look at how we can speed that up, but still do the process correctly. Sometimes speed can interfere with doing something right. You could think of like dispensing glue onto a surface. If you speed that up too much, you could start making things worse rather than better, as one example. So yeah, absolutely. I exist to help our customers solve any problem they come into contact with that relates to, you know, automation, things we can do with automation. So I can't necessarily help them with HR or anything like that, but anything automation related, we definitely can at least provide some help, even if that help might be, we're not a good fit for that, but here's a guy who is a good fit for that, and we're happy to make that connection. Hopefully that answers your question. If not, feel free to follow up.
Yeah, and if anybody else has any other questions for Brett, you can either unmute or put them in the chat. But yeah, that was an awesome overview, and I just think that's so cool. I studied engineering in college, and I was like, I just don't want to work on one project.
Right.
And I think it's really cool that people have the option, and, you know, sharing that people have the option. You can kind of do a little bit of everything is really interesting. We have one more question in the chat. What has been the most challenging product that you have been a part of?
Yeah, let me get to that. And I do want to respond to what you said. It's absolutely more fun in my mind to work on a ton of different stuff at once. So that's why I ended up where I ended up. So I could always do that. Challenging products. So, well, there's things that are technically challenging, which are, you know, just hard to make all the numbers work out from an engineering standpoint. But some of the things that I've gotten to be a part of that are probably a little more fun to talk about, but were also very challenging is one of the first robot projects I ever did was a guy who wanted to make orthotic foot soles for flip-flops. He loved flip-flops, sandals, and always felt like they never quite fit right. And so he had a goal of putting a 3D scanner in a mall kiosk, and so people could stand on the scanner and it would do a scan of their feet and get a profile of their feet. And then in real time, right while they're standing there, do all the necessary software conversions to make a model of their feet and figure out a cutting path. And then we used a robot to actually cut the foam out that is made the footbed so it would exactly match the person's feet. And it all had to work so that the average mall kiosk worker could make the system work. So we couldn't bring in somebody with an engineering degree to run the system. That would be too expensive. It just needed to be typically a high school student was the target worker for something like that. And they needed to be able to use this whole thing. So the whole thing had to be really well built to be able to do that. And that was a lot of fun.
Yeah, that sounds really fun. I want to try that.
So I'm not sure if he's still doing it. I think he did it for a while and he got it to work and it was working well. But I think he was one of those guys that after a while just kind of lost interest in the whole thing and decided to move on to the next project. Yeah.
Interesting.
And yes, it was very user-friendly. Absolutely.
Yeah. Awesome. Well, it looks like that's about all of the questions we have. I want to say thank you so much for joining and for your presentation and taking the time to answer all our questions today. It was great to get to learn a little bit about what you do and what In Possession Technologies works on.
Absolutely. Thanks for inviting me.
Of course. And thank you everybody for joining today. Again, the recording from our session today is going to be up on azamc.org in just a few days here. And you can also sign up there for our newsletter, learn a little bit more about manufacturing careers, and see how you can get connected with our network. Thank you all for joining.